नंदू।
So everyone joined. Hello.
यस सर।
Yes, sir.
Okay. Now what we do, instead of going for the videos, we will take the live lecture and then also record that lecture. And if possible, then I can share that lecture with you. Is it okay?
Okay, sir.
ओके सर।
So can we start now?
Yes, sir.
Now, are you getting the slide? Slide दिख रहा है तुम्हें?
Yes, sir.
No.
Yes.
यस सर।
हाँ. So what we do?
Yes, sir. Yes, sir.
We can use.
Sir, people with 2G connection are not able to see anything.
अब दिख रहा है? देखो.
No, sir. When
Yes,
you
sir.
present,
Yes, sir.
we are not.
अब ठीक है? हेलो, स्लाइड दिख रहा है आप सबको?
No, sir.
नो सर।
कितने लोगों को दिख रहा है?
Yes, sir.
Yes, sir.
Yes, sir.
So those having
sir,
4G
दिख रहा है।
connectivity are able to see it.
Yes, sir.
इसका हम एक काम करेंगे. देखो, लाइव लेक्चर तो क्योंकि इंस्ट्रक्शंस हैं कि आप उसी टाइम पे लेक्चर लो, ठीक है? तो एट मैक्स हम क्या कर सकते हैं कि अगर हम उसको रिकॉर्ड करेंगे तो हम शेयर कर सकते हैं, ठीक है? वो क्लास को हम शेयर कर देंगे.
Sir, can you use instead of presenting screen, can you use pen and paper? We will be able.
Actually, I have ordered the pen. It will come on Saturday. It is on Saturday. I can get that. That's why.
Okay, sir.
That's why I am using that mode, ना?
Okay, sir.
क्योंकि प्रेजेंटेशन भी, क्योंकि कुछ डायग्राम्स हैं उसमें टाइम निकल जाएगा. So from Saturday onwards, next week I am using that pen. Okay.
Okay, sir. Okay, sir.
So, and if the recording is there, and definitely I can share the recording with you. So can we start?
Yes, sir.
Yes, sir.
हाँ, मतलब दिख रहा है अभी सबको दिख रहा है?
Yes, sir.
No, sir. Yes, sir. Sir, all
Yes,
are
sir.
not able to see it.
नहीं, आप
No,
पीसी
sir.
पे यूज कर रहे हो. अगर आप देखो, अगर आप 2G कनेक्टिविटी में यूज कर रहे हो तो मैं कहूंगा कि आप प्रेफरेबली आप मोबाइल यूज करो.
Sir, we are using mobile phone. Sir, it happened before as well. Those having 2G connection, sir, we are not able to, see when anyone presents screen, we are not able to see it.
Yes, sir.
अच्छा,
Exactly.
तो फिर इसका क्या हल हो सकता है?
Sir, the pen and paper.
चलो मैं नहीं पेन एंड पेपर दिख रहा है, दिखेगा उसमें?
Yes, sir. Just like Kushal
सर
sir
दिख
is
रहा है
using
सर,
pen
पेन
and
एंड
paper.
पेपर।
नहीं, पेन पेपर दिखता तो है लेकिन वो थोड़ा ब्लर आता ना, क्योंकि डिजिटल पेन को हम ये अभी यूज करेंगे। मैं सैटरडे के बाद डिजिटल पेन ही यूज करूंगा।
सर कुछ नहीं दिख रहा
सर, बाद में रिकॉर्डिंग शेयर कर दीजिएगा ना।
सर। फिर आप रिकॉर्डिंग शेयर कीजिए इनके साथ।
बाद में थोड़ी समझ आएगा फिर।
ठीक है, चलो मैं रिकॉर्डिंग शेयर कर लूंगा।
Sir,
ठीक है,
sir, after the lecture, if you will please share with us the notes of this class so that we can.
चलो मैं एक काम करता हूँ। ठीक है, एक फाइनल क्या रहेगा कि जो मैं बुक यूज करूंगा,
Yes, sir.
तो उसका मैं आपको उस बुक का पहले से आपको पेज नंबर बता दूंगा। इज इट
सर,
ओके?
अभी ये स्लाइड आप मेल कर दीजिए ना, तो बच्चे स्लाइड खोल लेंगे।
Yes,
तो आप
sir.
पढ़ा दीजिएगा।
हाँ सर, सर वो भी अच्छा है।
चलो मैं स्लाइड मेल कर दिया करूंगा। ठीक है, चलो जो भी होगा मैं वीडियो तो आपके साथ शेयर करूंगा ही।
Yes,
सो कैन वी स्टार्ट नाउ?
yes, sir.
Okay, sir.
So, as we have discussed our power system protection last lecture also, that what is the power system protection and why it is required. So this is the whole syllabus of the power system protection. In this case, you will have 3 credits, and from the course details, you will see that you have the protective relaying, that is fundamental principles. Then what are the different type of relays which are used? Then protection system, that is the protection of generators. Then we have the transformer protection. Then we have the protection of feeders, bus bars, transmission lines, digital protection, and then the fuses. So this is all that you have to cover in this power system protection syllabus. Now, come to the lab. In the lab, you will see that many of the experiments are only study. That is study of various types of relays. Then you have characteristics of fuse, then burst time current relays, then time graded protection, and then study of circuit breakers. Then we have visit to electric substation, so it's not possible now. Then we have a study of differential protection. So all these things are covered in there, and maximum of the things in that are this study type. Now, come to the power system. If you see the power system, as you already know about the different things in the power system, that is, we have the generation system, we have the transmission system, we have the sub-transmission system, then we have the primary distribution system, then we have the secondary distribution system, and then the customer installation. So what is the voltage? Can anybody tell me the voltage at which this is generated, power is generated? Can anyone tell me?
22 kV.
11, 22. Okay. And 33 also sometimes?
Yes, sir.
Okay. So which are the main companies which are involved in that, in the power generation? Can you name a few?
NTPC.
NTPC, okay. It is taking care of thermal then?
NHPC.
NSPC. That's good.
NPCIL.
Which one?
NPCIL.
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 Okay. So these companies are involved in the power generation, and many of the power generation plants actually are owned by the this state governments also. So generation system, we are generating by different means, and then after that you have to increase the voltage for the transmission. So why the voltage is increased for the transmission? Can anybody tell me?
Decrease
reduce the losses.
Yes, sir. Sir, losses कम होता है sir.
Yeah, so to reduce the losses, we have to increase the voltage, and for that we are using the transformer. Okay. So which company is involved in the transmission?
PGCIL.
Power grid, sir.
Yeah, that is the dream company for your electrical engineers, because they are paying more than 80 lakhs package, PGCL. So whenever the companies will come and recruit, then you can definitely go for it. So then you have the transmission. Then after that, you have the sub-transmission. Sub-transmission system is actually used. Suppose you have the industrial loads and you need the high voltage for that industrial loads. And then you are having the 66 kV, 33 kV, and 132 kV. So the transformer is also used to reduce the voltage, transmission level voltage to the sub-transmission level. Then we have the distribution level, which is also known as the medium voltage level. After the medium voltage level, you have the secondary distribution. So for that, the transformer is also required at every level. And finally, it reaches your home. So from the whole of the structure, you will see that there are many components. Like in the generation system, we have the generator and transformer. In the transmission system, you have the in the generator system, you have generator, transformer, and bus bars also, because every wire is connected to the bus bar. Then after that, you have the transmission system. In the transmission system, you have the transmission line, and after the transmission line, you have this transformer also. In sub-transmission system, you also have the transmission line and this transformer. Then in the primary and secondary distribution, at every level, you will have the transmission line as well as the transformer to reduce or increase the voltage. It depends upon the utility. And so at every level, these components are there. And what you have to do, you have to protect these components, because whole of the system is an interconnected system. Whole of the power system is an interconnected power system. And whenever suppose that if something happens at one part of the system, then whole of the system can be disturbed out of that. So this is actually the primary system. So it consists of primary and the secondary system. So it is the primary system. Now, what is the secondary system? We can discuss. Now we will have in the secondary system, we will have the protection. That is, we are dealing with it. Then we have the control of voltage, frequency, reactive power, compensation, power flow, network reconfiguration, and stability. So what is the reactive? Can anyone tells me what's the reactive power compensation in that? Anyone? What do you mean by reactive power compensation? Anyone know about what is the active power and what is reactive power? What's the difference between these two powers? कौन बताएगा?
तो सर करंट वोल्टेज कितने आउट ऑफ फेज होता है, वो होता है रिएक्टिव पावर सर.
आउट ऑफ फेज क्यों होता है?
Sir, the power required for transmission is known as reactive power, and the power, sir, which actually used is known as active power.
Power required for transmission.
Wastage of the power which occur in transmission.
Not perfect definition. Any other?
Sir, those power flow from load to source.
What?
Sir, those power flow from load to source, that is reactive power. Those power flow from source to load, that is reactive power.
From load to source. No, it's wrong concept. Any other?
So that power which does not take part in energy conversion is called active power, reactive power.
So why it is useful? Okay, that's fine. So why is it useful?
Yes, sir?
Why is it useful? एनर्जी कन्वर्जन में यूज नहीं होती, लेकिन क्यों यूज होती है?
कैपेसिटर में यूज होती है. मतलब सर जो मतलब इंडक्शन मोटर्स हैं उनमें यूज होती है, क्योंकि उनको मतलब यूनिटी पावर फैक्टर पे नहीं चलती है. उनमें मतलब वो करंट और वोल्टेज में लैग करती है, मतलब करंट लैग करती है, इसीलिए हमें.
ये चलो एक एस्पेक्ट है इसका, लेकिन आप क्यों रिक्वायर्ड है? क्या रीजन है रिक्वायरमेंट की? क्या रीजन है? Because it is very important part. Whenever you are going for any interview, they will ask the active and the reactive power. Active power, reactive power, and power factor that what's the physical significance of these things, they will ask, they will definitely ask. So you will see that 80% of the loads that we are having, they are actually inductive loads. You know that? तुम्हें पता है ये inductive load है? 80% of loads that we are using.
Yes, sir.
So how is it inductive load? ये inductive load कैसे हैं? Because if you see every load, 80% of load that we are discussing, it is winding. वो क्या है? Winding. Winding is wound. ठीक है?
Yes, sir.
So when the winding is wound, then in that very case you will see that it is a kind of inductor. So if it is a kind of inductor, then as we have seen in case of a resistor, the voltage and current is not in phase with each other and are out of phase. It depends upon the value of inductance. Okay. यहाँ तक clear हो गया आपको?
Yes, sir.
So if you see that whenever every kind of load, 80% of load that we are discussing, it's inductive load, it's a winding. So when the winding is wound, the current and voltage are not in phase. These are out of phase, and as a result, it is inductive. And because of the inductance, always the reactive power is there, that you know. But why it is required? Why it is required? You will see that when the winding is wound, then what happens in that? Whenever the current is flowing in that particular winding, then you will see that it will create the flux.
Yes, sir.
क्या बनाएगा वो?
Flux, magnetic
Flux
flux, electric
create
flux.
करेगा. Flux create करने से क्या create करेगा वो? Magnetic field. Okay, is it okay?
Yes, sir.
That winding will create the flux, that winding will create the magnetic field, and depending upon the voltage, depending upon the magnetic field it is required, हम उतनी ही करंट उसको देते हैं. Okay? Is it clear?
Yes, sir. Yes, sir.
तो उसमें क्या होता है कि जितनी हमें वोल्टेज रिक्वायरमेंट होती है, हम उतनी ही मैग्नेटिक फील्ड जनरेट करते हैं, और जितनी मैग्नेटिक फील्ड हमको जनरेट करनी है उतने हम नंबर ऑफ टर्न्स क्रिएट करेंगे. समझे ना बात? तो जितना वो वोल्टेज जनरेट करेगा उतनी ही रिएक्टिव पावर रिक्वायरमेंट होगी. सो दीज आर इंटरकनेक्टेड. इट मींस that it will provide such a voltage level so that the active power can flow through it. Are you getting my point?
Yes, sir.
समझ आया अभी आपको? देखो क्या है कि हमें किसी वर्क के लिए एक वोल्टेज जनरेट करनी है. सो किसी वर्क के लिए हम we have to create a voltage. Please mute the mic. हमें किसी इसके कोई काम करने के लिए हमें एक पर्टिकुलर वोल्टेज जनरेट करनी है. वो वोल्टेज कैसे जनरेट होगी? आप बैक चलिए. वो जनरेट होगी जब हमारे पास मैग्नेटिक फील्ड होगी. मैग्नेटिक फील्ड कैसे होगी? मैग्नेटिक फील्ड तभी होगी जब हमारी नंबर ऑफ वाइंडिंग्स होंगी, और वो तभी होगी जब फ्लक्स होगा. सो इट मींस इट इज इंटरकनेक्टेड. सो इट मींस द रिएक्टिव पावर इज रिक्वायर्ड so that the particular voltage is maintained so that the active current can flow through it. बात समझ गए आप?
Yes,
Is it
sir.
clear?
Yes, sir.
It is similar to that. If you see, let us suppose that you want to cross a bridge. So bridge को क्रॉस करने के लिए तुम छलांग मार के तो नहीं क्रॉस कर सकते. तो आप क्या करोगे? एक वहां पे एक वो बनाओगे, ब्रिज बनाओगे. You want to cross some river, so bridge बनाओगे. So bridge is active. It is acting as a reactive power, and you are moving in that. You are doing actual work. It is a reactive power. There are numerous examples like that. Is it okay? So one more example, you will see that if you have a cold drink is there. So आप सभी पीते हो कोल्ड ड्रिंक? वैसे नहीं पीनी चाहिए. तो उसमें कोल्ड ड्रिंक में क्या होता है कि जब आप उसकी बोतल खोलोगे तो कोल्ड ड्रिंक में क्या होगा कि नीचे आपका वो होगा, कोल्ड ड्रिंक होगी और ऊपर जो है
गैस
हाँ ठीक है। तो
और
वो
रिएक्टिव पावर
रिक्वायर्ड
लिखा
है,
हुआ है।
वो ऊपर क्यों रिक्वायर्ड है? जो ऊपर वाला पार्ट है वो रिएक्टिव पावर है, नीचे वाला एक्टिव पावर है। ऊपर वाला इसलिए रिक्वायर्ड है ताकि वो फ्रेश रहे। इज इट ओके?
यस सर।
So that's why the reactive power is always there. Whenever you are having the winding, the reactive power always exists, and active power is the useful work. Okay, because not all the networks are actually the these resistive networks. Maximum of the networks are the inductive networks. Now come to the third point, that is metering for billing, operational control, and statistical data. These are actually the secondary systems. Then we have the local control, that is voltage level reactive power support. Then we have the network reconfiguration. Then we have the remote manual control via communications. Then we have the condition monitoring and alarming, that is what's the condition, temperature, and all that aspects in the power system. Then we have the communication in infrastructure. Communication infrastructure is also required for faults and various things. Then we have the instrument transformers, current and the voltage transformers. So in this case, in the secondary system, we are discussing only the protection system. So as somebody said about the capacitor, that what's the why the capacitor is used? हम capacitor क्यों use करते हैं? Anyone?
सर कंपनसेशन
के लिए
किस चीज के कंपनसेशन के लिए?
पावर फैक्टर।
हाँ, पावर फैक्टर। और पावर फ्लो, आपने जब सब्जेक्ट पावर फ्लो का पढ़ा था तो आपने ये भी पढ़ा होगा कि जब भी हमें रिएक्टिव पावर फ्लो करवानी है तो हमें क्या करना पड़ता है? किस चीज का डिफरेंस क्रिएट करना पड़ता है? पावर फ्लो क्वेश्चन पढ़ी है सबने, पी और क्यू आपके उसमें होंगी पावर सिस्टम में। पावर फ्लो क्वेश्चंस पी एंड क्यू पढ़ी है सभी ने?
यस सर।
हाँ, तो एक्टिव पावर किस पे डिपेंड करता है? एंगल के ऊपर, ठीक है? क्योंकि इसमें क्या होता है, v1 v2 डिवाइडेड बाय x इंटू साइन ऑफ डेल्टा। तो एक्टिव पावर किस पे डिपेंड करता है? एक्टिव पावर डिपेंड करता है इसके एंगल के ऊपर। और रिएक्टिव पावर किस पे डिपेंड करता है? कौन से फैक्टर पे डिपेंड करेगा बताओ?
मैग्नीट्यूड के डिफरेंस,
वोल्टेज के ऊपर, वोल्टेज मैग्नीट्यूड। और उसका जो एक्टिव पावर फ्लो करेगा, फ्लो डिपेंड करेगा एंगल डिफरेंस के बीच। ये आप लोगों ने पढ़ा है ये पावर सिस्टम में? पावर फ्लो इक्वेशंस पढ़ी होंगी।
ये सही इसी सेमेस्टर में
यही कॉन्सेप्ट है ना? क्या कह रहे हो
सर? ये टॉपिक इसी सेमेस्टर में है हमें, पावर सिस्टम थर्ड में।
हाँ, ये पावर फ्लो इक्वेशन, जो एक्टिव पावर है वो एंगल डिफरेंस पे डिपेंड करेगी और रिएक्टिव पावर जो डिपेंड करेगी वो वोल्टेज डिफरेंस पे डिपेंड करेगी। अब देखो, व्हेनेवर सपोज कि हमारे सिस्टम में जो है हमारे, लेट अस सपोज दैट एक हमारा जनरेटर है एंड देन वी हैव द लोड। आप अज्यूम करो, अभी मेरे पास लिखने के लिए यहाँ कुछ नहीं है, तो आप इस चीज को अज्यूम करो। नेक्स्ट सैटरडे से मैं लाइव ब्लैक बोर्ड भी यूज करूंगा। सो यू विल सी दैट वी हैव अ जनरेटर एंड यू हैव द लोड, ठीक है? लेट अस सपोज दैट हमारे पास लोड के साइड पे हमारी रिएक्टिव पावर रिक्वायरमेंट बढ़ गई, मींस हमने लोड ज्यादा डाल दिया। तो जब भी हम लोड ज्यादा डालते हैं, इट इज द रिएक्टिव पावर विच डोमिनेट्स एज कंपेयर टू द एक्टिव पावर। यहां तक समझ आ गया आपको? इज इट ओके?
Yes,
we
sir.
have a generator and we have the load, and let us suppose that we switch on the load. लोड हमेशा पैरेलल में होते हैं, ठीक है? जब भी पैरेलल में होते हैं, पावर रिक्वायरमेंट कम्युलेटिव जो है रेजिस्टेंस डिक्रीज हो जाता है और रिक्वायरमेंट बढ़ जाती है। तो एज ए रिजल्ट यू विल सी दैट द रिएक्टिव रिक्वायरमेंट विल इंक्रीज। अब जब रिएक्टिव रिक्वायरमेंट हमारी लोड साइड में इंक्रीज हो गई, then you will see that in that very case, if the reactive requirement of the load increases, तो वो लोड की रिक्वायरमेंट कहां से आएगी? सपोज हमारे पास सिर्फ एक जनरेटर है, तो कहां से आएगी फिर वो?
एक्सटर्नली कंपनसेट करना पड़ेगा।
नहीं, पहले हम सिनेरियो देखेंगे ना, हम उसको लगाएंगे क्यों, हम मतलब पहले हम उसकी पूरी भूमिका बनाएंगे कि उसको क्यों लगाना है हमको। तो वो उसको प्रोवाइड कौन करेगा? जनरेटर प्रोवाइड करेगा। व्हेन हमने कंपनसेशन कुछ नहीं है तो हमें क्या, कौन प्रोवाइड करेगा उसको?
जनरेटर
प्रोवाइड करेगा, ठीक है। अब जब जनरेटर प्रोवाइड करेगा, एज पर द पावर फ्लो इक्वेशन यू विल सी कि रिएक्टिव पावर किस पे डिपेंड करती है? वोल्टेज मैग्नीट्यूड डिफरेंस पे। बात को समझे? इज इट ओके?
यस सर।
हाँ, तो ज्यादा रिएक्टिव पावर फ्लो करने के लिए हमें क्या करना पड़ेगा? वी हैव टू क्रिएट ए डिफरेंस बिटवीन सेंडिंग एंड एंड द रिसीविंग एंड वोल्टेज, ताकि हमारा जो जनरेटर है वो उसको प्रोवाइड कर सके। ओके, इज इट ओके?
यस सर।
तो क्या होगा कि हमारा जो सेंडिंग रिसीविंग एंड वोल्टेज है वो रिड्यूस हो जाएगी, हम एक्स्ट्रा उसके लेने के लिए, एक्स्ट्रा रिएक्टिव पावर लेने के लिए। तो इसलिए we don't want to do that. For that, what we do, we use the locally compensate, we want to compensate it locally. That is what we do. We use the capacitor or any other device for this. Many of the FEC devices are also there. Like you have SVC is used, like we have the STATCOM is used. In many of the power grid projects, you can see SVC and the STATCOMs are used. So for that, we provide the reactive power locally. तो हम क्या करेंगे? रिएक्टिव पावर लोकली प्रोवाइड करेंगे, और जब हम रिएक्टिव पावर लोकली प्रोवाइड करेंगे, इट मींस दैट देयर इज रिएक्टिव पावर कैन नॉट फ्लो थ्रू द जनरेटर, तो वो जनरेटर से फ्लो नहीं करेगा। तो इसका मतलब है हमें वोल्टेज डिफरेंस क्रिएट करने की जरूरत नहीं है। इज इट ओके? आर यू गेटिंग माय पॉइंट?
Yes, sir.
So that's why it is that's why we are providing the compensation, and you must know these concepts, because these concepts are very important as per your, from the interview point of view, because they will ask you about that. Now in this case we will discuss the protection system. Now here we have the substation fire. You will see that because of the non-functioning of some of the equipments, protection equipments, the fire will take place. So this is the substation fire, and this is after that. You will see that many of the things are involved in that infrastructure investment. So everything is disturbed because of the malfunctioning of this protection system. Now this is the transformer fire, which is due to the fault. This is one of the example of that. Then we have the generator faults. So how this? It is because of this non-functioning of many of the protection equipments, the fault will occur. Now these are actually the expensive consequences of the fault, that much of the amount and much of the this investment which is involved in that, it is destroyed because of that. So we have to take care of that. As a protection engineer, you must know the basic concepts. Now, as you have already discussed that, we have discussed in that lecture also that I shared with you. So what is a protection scheme? It is designed to continuously monitor the power system to ensure the maximum continuity of the electrical supply with the minimum damage to life, equipment, and the property. So we design in such a way that we can prevent the damage to life, equipment, and the property. However, at max, what we can do, we can avoid the prevention, but we cannot fully control that thing. Now, designing the protective schemes. When we are designing any protective scheme, we must know the characteristics of the individual fault elements. That is, fault characteristics should be there, that how they react when the fault will occur. Then we have the knowledge about the characteristics of various tripping relays which are using, which we are using for the protection purposes. And also the what's the job of the protection engineer? Protection engineer, if you want to work in the protection field, then your job is to match the these characteristics, that is the fault characteristics of a power system and the tripping characteristics of protective relays. So you have to match these characteristics so that a perfect protective scheme should be designed. And also you have to make sure that the relay will not trip for undesirable conditions. Like you have the undesirable conditions, like when you are starting the motor. In that very case, the starting current is very high in that very case. Also, when you are increasing, when you are starting the transformer, then the inrush current is there that we can discuss. So that undesirable conditions should be detected, and they should not see it as a fault. So that should also be there, and that's the responsibility of the protection engineer, that you have to make sure that. So why study the power system? So it has been observed that the relay trippings are due to the improper settings than due to the genuine faults. If you many of the data engineers are doing work in different fields, and one of the evidence is that the relay, whatever whatever fault is occurring in the power system, is due to the inadequate settings, because everything is left to the operator. Operator can set as per his understanding and as per his experience. So as a student, it is required that you should be equipped with the concepts of power system protection to enable you to handle these kind of circumstances. So protection, it depends upon your experience, that how you see the things. Let us suppose that some fault occurs, then you have to see in a different way. You have to use your experience. So this and this fault occurs at that very particular point of time, so it may be like that. So that thing came with the experience, but you should be equipped with the basic concepts of that. Now, one more point is that it is very interesting subject. That is, let us suppose that some tripping is occur in power. Let us suppose that someone is working in power development department or any other PSUs. Then if fault occurs, then at that very particular point of time, you should become the detective. You should be detective at that particular time, because you must know that what is happening, how it happens. So it involves the drama and suspense in that. And the detective work is also involved in that. That you have to see. Let us suppose that some fault occurs in this transmission line of power grid. Then first you have to see, you have to do the preliminary investigation and that what is happening. After that, you can see the whole of the line, that thing is also there. So you need a kind of a very critical thinking and subjective thinking in that particular work. So whenever, let us suppose the relay trips, then you should know that why this relay trips. Let us at your home, let's suppose that some fault is coming. Because of that, fuse blows or tripping is there in MCB. So you must know that how it happens, from where it happens. Suppose you are using a 16 ampere some device in a socket of 5 ampere, then the relay will definitely trip. Then definitely you can know that, okay, I'm using this, so relay will trip. So these kind of things you should have in mind. It's a very interesting subject as per this. So you should know that what are how the fault occurs, where is the fault. That thing you also know because of the concepts and with experience. Also, one more point is that the power system is a very complex subject and dynamic entity. That is, you cannot say that it's a static entity. It's moving. It's a dynamic entity. Loads are everything is online. Sometimes you are having the load and sometimes you don't have the load. So it's a dynamic entity. So also sometimes we will have the generators will be out of service, new loads will be added, and some faults would be there because of interconnection. The complexity will also increase. We will have the interconnection in the system, and because of that, complexity is there. So that thing should also taken into consideration whenever designing this protection system. And as you know, that power system is very complex. Now, for that, from this, you will know that you will need a surgical accuracy against the fault that came with the this experience only, and that is only insurance against the large losses due to the faults. Fault is not every day phenomena. You can have the large faults after some years. You will see some blackouts and all this. But the protective relay or the protective system should be designed in such a way that you can, whatever is the fault, it can detect and then isolate it. Now, some of the elements of the power system, like we will have, if you see the slide, then we will have this transmission line is taken. Then we will have the CT and PT. These are actually the transducers. That is, what's the CT and PT is? That is current transformer and the potential or the voltage transformer. You will see that this transmission line is of high voltage. And device that we are using, that is these relays, these are actually the low voltage. So for that, we need some kind of device so that from this high voltage, we can work on the low voltage. We cannot work on the 11 kV, or we cannot work on suppose 765 kV transmission line. So for that, what we do, we are using CT and PT. It will reduce the voltage and the current level, and it will give this signal to this relay. And relay are actually DC. These are operated by the DC. These are the set of the batteries which are used for that very purpose. And then when the relay will operate, as per the logic, it will make or break the circuit. If suppose it wants to break the circuit, in that very case, it will give the signal to the circuit breaker, and the circuit breaker can work accordingly. So in this case, you will see that this is the brain of this everything. That is, we are getting the signal from this. Then after that, this will decide whether this relay will decide whether circuit breaker will make or break the circuit. Now, different elements like we have CT/PT. It is used to provide the current and voltage signals to the relays to detect the deviations in the parameters. And then after that, we will have this relays. These are actually the logic elements which initiate the tripping and closing operations. So these are actually the logic elements. And after that, we will have the circuit breaker that isolate the fault by interrupting the current in that very case. Now, this is whole of the system. Now, this is for this relay, we want some power, and we cannot rely on this already system which is under fault on that. So for that, external supply is used. That is, we are using the DC for that. So DC battery is used for that very purpose. Now, this is all about the CTs and PTs. So, and the one more point is that the failure of one of these components is treated as the failure of the protective system. Now, what is the work of as a protection engineer? So, whenever you are adding the relay to the system, then in that very case, the complexity increases because one more relay characteristic is increased. So there is the more possibility of the mal-operation of that relay. So in this case, you can see that you have to work very artistically, and you have to work very objectively in that very case. So as a protection engineer, you have to strike a balance between what is the threat and the security offered by the protective scheme. So the work of the protection engineer is very complex. That is, you have to take into consideration all the relays, and if the complexity increases, then it would be more difficult for you. Now, dependence of the modern society on electric supply, that is, you have to see that everything is dependent on the electrical supply. So it's a reliable availability of electricity is very much required, and quality should be high. Quality high means that there should not be dips, there should not be flickers, and all that aspect should be there. And one more point that like we have the computer and telecommunication networks, then we have the railway networks, banking and post office networks, and numerous other industries. Or you can say that nowadays our life cannot function without the reliable source of power, because for everything we are using the power. In our online classes, without power, we cannot have that. So also the number of domestic users there is also increasing day by day. So now it is on these engineers, it is on the electric company to make sure that you should have the continuous supply of electricity around the clock. So and the reliable supply that should be there in the modern world. So one more point is that no power system can be designed that it would never fail. So we cannot, as a protection engineer, if you are perfect, but still sometimes you cannot prevent the fault. So that thing should also be taken into consideration. And in the language of protection engineers, these actually failures are known as the fault. And one more important point is that the protection engineer is more concerned about for the prevention of the fault than to mitigate its consequences. That is, its consequences are very much fatal. A large amount of machinery, man, and investment is involved in any project. So how to prevent the fault, it is the main function of that protection engineer. And what the protection engineer can do, he can design the system in such a way that whatever is the faulty connection, he can isolate that particular faulty element from the rest of the healthy system, so that the disturbance is maintained. The disturbance is that is mitigated, and it can be in a very small area in time and space. So the complexity in the protection system is increasing because of you will see the interconnection of the system. So you know that why the system we are using interconnected system? Any idea that why we are using the interconnected system nowadays? Anyone?
Sir, if fault occurs at one place, we have another source to compensate that.
Okay. So how many grids are there, national grids? We have the 5 zones. Do you know the 5 zones? You must know these zones. Actually, whenever you are preparing for any interview, they will ask the electricity distribution transmission specific.
Sir, we are under north zone, I guess.
Yeah, we are on north zone. You should, whenever you are preparing for interview, or you must, as an electrical engineer, you must know that what are different zones of this grids. What are different grids? Then what are different zones, and what company is involved in that? Then what's the maximum transmission voltage? So what's the maximum transmission voltage nowadays? The power grid is only the transmission utility which is doing that. So what's the maximum transmission voltage? Anyone?
So 765 kV.
765. Yeah, we are mainly now using 765, and we are also increasing because the power grid is working on some projects more than 765. So that thing you should also know. What's the maximum thermal generation? What's the maximum hydro generation? That thing you should know. You should update yourself as per the requirement, because they will ask about that. And also we will have, if you see the power sector in the state, so we will have in some of the states we have the corporations, and in the corporations you will have the 3 entities in the power structure. So what are the 3 entities in the power structure in a corporation? Anyone? कौन सी 3 एंटिटीज हैं? सपोज एक हम किसी का स्टेट में कारपोरेशन है, तो कौन कौन सी एंटिटीज वहां पे यूज होती हैं जनरेशन ट्रांसमिशन के लिए? हैव यू हर्ड अबाउट जेनको?
No, sir.
So in the transmission, if we have the corporation, let us suppose nowadays what the system is like, that whole of the power development department of many of the states is converted into corporation. And in the corporation, we will have the 3 sections, like we have the Genco, Transco, and Disco. It means that generation company, transmission company, and the distribution company. That is, first one is generating, then it is transmitting, and it is distributing. It is within the state only. State government is doing that. It is because to increase the efficiency, because the maximum of the companies, previously the maximum of the things, these are as a whole department. But nowadays they have converted into corporations. The generation, Genco will take care of the generation, Transco will take care of the transmission, and Disco will take care of the distribution system. So this is known as the unbundling. So do you know about the what is the so we will discussing about the power system, that why it is interconnected. So these points you must note down, and these you should update yourself, that what's the total generation. Nowadays we are using the solar plants and wind plants also, that should also be included, because you are not after moving out from here, maybe whenever you are going for any interview in industry, then you should be confident of that what's the generation, what are different plants, and the state. Let us suppose that you are from the state, then you must know about the different generation scenario of that particular state. So that thing is there. So this is all about the first introductory lecture. Is it okay?
Yes, sir.
Yes, sir.
Are you getting?
Yes, sir.
Yes, sir.
Yes, sir.
So the thing is that we can we can discuss the things, and anyone have any doubt, you can mail me, you can call me. That's not an issue. But the issue is that since you are in 7th semester, so you have to work hard, because the nowadays the competition is very high. So you have to work hard. You have to update ourselves in the update yourself as per the subjects, core subjects. And this power system protection is very much core subject. You can say many of the people are asking the questions on the protection. And if you study this subject, it's a very interesting kind. And you can easily grasp the concept. They simply ask that how you protect the generator, how you protect the bus bar, and all these concepts they will ask. So you should grasp that concept, so that in future you can have. So one question is that there, interconnect to increase the reliable operation. Okay. Zoom, we cannot use. Someone is asking that to try Zoom app. Actually, we cannot use the Zoom because the instructions are there that because it's an official account, so nobody can enter it. But in Zoom, anyone can enter. So that is a risk in that. So that's okay for now. Is it okay?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So we can
Yeah.
together we can study, and together we can learn. It is not like that I am teaching you and then you have to learn only. I also learn. So we both have to work together. Okay.
Sure, sir.
Okay, then for the next lecture I will update you, and then we can next lecture we can discuss in the next thing we can discuss in the next class.
Sir, the attendance.
Yeah?
Attendance, sir.
अटेंडेंस आप एक काम करो, जो आपका सीआर है आर्यन, हाँ
सर,
हाँ, तो आर्यन को बोल दो कि एक एक्सेल फाइल बना ले, ठीक है।
ओके सर।
तो वो एक एक्सेल फाइल बना ले, तो जो उसमें प्रेजेंट होगा वो मेरे को वो उसमें वो इंटर करता जाएगा। ठीक है आशीष?
यस सर।
हाँ, जो भी उस टाइम इंटर होगा वो उसमें आप उसको इंटर कर लेना। ठीक है? ओके 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 देन
Okay, sir.
हैव अ
Thank
नाइस
you.
टाइम। थैंक यू वेरी मच।
Thank you.
Okay.